Look at this. It's cool, right? In this video, we will learn how to import animations, transition between them, perform a dash, and make visual improvements. Let's learn how to do this.
Musha
Yep, we are inside a new third-person template project. By pressing the Control and Space keys, we open the content browser. Let's create a colored folder for our character. I import the model and the animation I created in Blender. I create folders for animation, material, and character. Not strictly necessary for now, but the more organized, the better. Inside our animation folder, let's create an animation blueprint. In this part, we should select the skeleton that belongs to our character. We will set up our character's walk and dash animations inside this animation blueprint. I'm going inside. Yes, a whole new world, but don't be intimidated. The logic is very simple. Let's add a state machine node. We will build all our animations inside the state machine and connect it to the output pose node, and their character will be able to move. Double-click the state machine node to go inside. Right-click the empty area and choose Add State. This will be our idle animation. We must connect it to the entry node, otherwise it will give an error. I add another state. This will be our walk animation. I double-click and go inside. In the Asset Browser tab on the right, we see the walk animation we imported. I drag and drop it and connect it to the output animation pose node. I didn't make an animation for idle, so we can just leave it in the default state. I connect the nodes to each other so that it can transition between walking and stopping, and from stopping to walking. Click the connection between idle and walk and go inside. Here, we will make the settings required to transition from the idle pose to the walking pose. Create a float variable named speed. While holding the Control key, drag and drop it. Add a greater node and connect its output pin to the Can Enter transition pin on the result node. Enter 10 for the speed value. By the way, if you select the nodes and press the Q key, it arranges them on a horizontal plane. Dude, what happened again? Okay, we didn't set up walk to idle. These things happen, relax. Let's do it. Actually, we will do the exact opposite of what we did when transitioning to walking. I think you understand the logic. Drag the speed variable, add a less node, connect its output pin to the result node, and enter the value 10. Thus, if it's above the value 10, the walking animations will play. If it's below, the idle animations will play. Let's go into the third-person character blueprint and replace our default character mesh with our Hornet character. Seems a tad big. Let's adjust its size and orientation. Okay, let's compile and start the game. Let's see if our animations will work. Of course it won't, because in the Anim class, the animation blueprint we prepared is not selected. Let's select it right away and see if it's working. No? Why do you think it didn't work? Because we didn't write the code that will trigger the animation blueprint. Yes, up to now, we arranged the ingredients but didn't cook them. I mean, something like that. Let's go into the event graph. From the return value output of the try_get_pawn_owner node, call the getVelocity node. Connect a vector length node to this, and while holding the Alt key, connect our speed variable to the return value output. I connect our variable to the event blueprint update animation node. Node works like event begin play for animation blueprints. It is triggered when the game starts. Let's set our variable and connect it with the cast2bp third-person character node. This way, we will be able to access our character blueprint's information. From the AsBP third-person character pen, let's call character movement and connect it to the getCurrentAcceleration node. Let's copy the vector length node and connect it. Similarly, let's copy our speed variable and connect it to vector length. With cast2, let's also connect the pins of the speed variable. Connect the return value pin of the try_get_pawn_owner node to object on the cast2. And that's it. Let's compile and start the game. Yes, our walk animation is playing. But as you can see, this time there is another problem. I guess our character got a cramp in the leg. Why do you think this happened? Yes, our animation is not looping, friends. Let's fix that immediately. I go into the walk state and click my animation. From the details panel, I enable the loop animation option. Let's compile and see. Finally, Hornet is no longer paralyzed. Well, since it can walk now, it should be able to dash too, right? We are in the character blueprint. Let's start dash coding. I add a key event so that it works when I press the E key. I drag and drop character movement, and from its output pen, I call the set gravity scale node and connect it to the E event. As you would guess, this node will reduce gravity to 0. From here, I call the launch character node. This node will also apply the push to our character. I call the set actor rotation node and connect it to the forward vector node. Set actor rotation provides our character's orientation information, and the forward vector takes this information and passes along where the character's front is. From the forward vector return value pen, I call multiply. Right-click the value part and select float. Let's enter the value at once so we don't bother. Connect this to the launch velocity pen. Enter a value. Yes. Did you get the logic? I press the E key, and for my character movements, gravity is set to 0. After that, my character's orientation information is extracted, the front side is found, a push force of 500 times this value is applied. I hope I could explain. We don't want the character to stay in the air after the dash is over. That's why I copy my set gravity scale and character movement nodes. I add a delay and enter the value 0.5 and connect them to each other. I set the gravity scale value to 1 because the default value of gravity is 1. Finally, I call the stop movement immediately node. We will end the dash movement this way. Let's compile. Oh, sorry, we didn't connect character movement to the target pin of the stop movement immediately node. Now, let's dash a little, please. What the f***? I guess with this dash, we can't even beat the first boss. Let's increase the push value. Finally! But what's this? Do we stand straight like a flagpole while dashing? Let's have a dash pose. We will actually do something very similar to what we did for the walk animation. Let's import the file I prepared for the dash. The point we need to pay attention to here is that in the skeleton mesh part, we should select our character's mesh, then press import and let it go. Here, we only need the animation sequence. We can delete the others. Let's open our animation blueprint. As you can see, our animation came into the asset browser. Let's go into the state machine and create a new state named dash. Yes, we connect everything to each other. We go into the dash state and drag and drop our dash animation. We go into the walk to dash connection. We make the coding of let it run if the speed variable is greater than 1,000. We do the same for idle to dash. And the opposite, that is, the coding of let it run if it's less than the value 1,000. I do it for dash to idle and dash to walk. Let's compile and see if it's working. Yes, sir! He doesn't fly like Superman anymore. Now we've come to the camera effect part. We are in our character's blueprint. I create 2 custom events, one for the start of the effect and one for the end. I create a Boolean variable so that it can be checked whether the effect is applied or not. I drop it into the event graph to not Boolean and connect that to the condition pin of the branch node. I set the Boolean variable on the true pin of the branch node and mark it as true. Thus, we are saying this: if the FOV effect hasn't been applied, apply it. Let's add a timeline and go inside. By pressing Shift and left-click, I add 2 pins. I set the first to 0, 0 and the second to 0.1, 0.1. Thus, we will create the effect for 0.1 seconds. For a smoother effect, we can select the pins, right-click and choose Auto. As you can see, an alpha pin came to the timeline node. From this pin, I call the lerp node. Let's create a float variable that will define our camera's position before the effect. I drag and drop the follow camera component, and from here, I call the get field of view node. I set our float variable here and connect it with our Boolean variable. Let's also connect the play pin of the timeline node with the output pin of our float variable. Right now, we have set the starting points of the FOV effect that will be applied to the camera. I drag and drop our Boolean variable. From its output pin, I call a branch node and connect it to the custom event we created for the end. I also connect the true pin to the reverse pin. By the way, the shortcut to call a branch node is to press the B key together with left click. There are such shortcuts for frequently used nodes. I'll show them as we encounter them. Yup, we call the set field of view node and I connect it to the update pin on the timeline. I connect it with lerp like this. We connected the alpha pin to the wrong place. Let's fix it. Let's connect our float variable to the A value. From the output of the variable, I call the add node and connect it to the B value. Enter a value. Yeah, I think you understood the logic. The first pin we created inside the timeline is the A value. That is the initial state of our camera. The second pin is the B value. That is the second state of the camera, the state with the effect applied. From the direction pin on the timeline, let's call the equal enum node and create a branch on its output pin. With the branch, I connect the finished pin. Let's get to the code we created for dash. We want the effect to start when we press the E key and to end when the dash is completed. Therefore, from the output pin of our key event, let's call our custom event that starts the effect. For the end of the dash, let's call the custom event we created for the end. Yes, we need to select this option as backward. Otherwise, the camera stays where the effect is applied and doesn't return. And by the way, we should set our variable on the branch node and leave it as false. Let's try and see. As you can see, it applies the effect, but the camera doesn't return. Let's also try selecting backward. Yes, it returns, but I guess we gave the effect value too low. Let's increase it a bit. And voila! We now have a much sexier dash effect. I also wanted to see it by decreasing the value instead of increasing it. Let's see how it will be. I mean, maybe you prefer it like this. Your choice, of course. Alright, we've arrived at the VFX section. Let's get started. I am adding the Niagara system. Click the Create Empty Niagara System button. Let's go inside. And we are in a whole new world again. I think let's go through this part quickly. Just follow along. Right-click, Add Emitter, Add Minimal Niagara Emitter. Let's click the Properties section. From the Details panel, after GPU Compute Sim, select the Fixed options. Let's click the Initialize Particles part. I set the lifetime value to 0.2. As color mode, I select the Direct Set option. Let the color stay white. I also set the alpha value to 0.2. I click the icon next to Particle Spawn. I select the Initialize Mesh Reproduction Sprite option. In the Mesh part, I select our character, and I click the Fix Now button. I click the Emitter State part, mark the Life Cycle mode as Self, and set the loop duration value to 0.2. I click the icon next to Particle Update and add Scale Color. I click the arrow next to Scale Alpha and add Float from Curve. Right-click and let's add a pin. I set it like this. Let's add a spawn rate to the emitter update part, and its value, I set it to 300,000. In the initialize mesh reproduction sprite part, I increased the particle scale value, and that's it. Let's go into our character blueprint. While skeleton mesh is selected, let's choose Niagara Particle System component. In the Niagara System asset part, let's select the effect we created. And yeah, we turned into a ghost. I drag the dash effect into the event graph, and from here, I call the set active node, and I tick it. Thus, when we press the E key, the FOV effect will run, and then our dash effect will run. I add the same for the end as well, and untick them. Let's compile and start. What's happening, man? Okay. Let's click our dash effect. If we turn off the auto active option in the details panel, we prevent it from starting with the effect when the game starts. Now let's see. Yes, our dash effect is ready, but I want it to look like wind, and our dash pose doesn't show this way, it seems. Let's fix it. I return to the Niagara system. I reduce the spawn rate value. 20,000 seems good. Let's see how it turned out. That's it, my friend. Now I can get hired at Team Cherry. Let's also see it in the level I prepared earlier. Look at this! I feel very cool right now. Let me remind you again, you can access the Hornet model, animations, and project files for free through my Patreon account. Link in the description. Please ask in the comments about the parts you didn't understand. If you have suggestions, write them. And I should warn you before you go, you should subscribe. Otherwise...